Hi everyone, in this video we're going to look at the 5-number summary and box plots. So here's a sample data set. This is not real-world data, but it is a real-world context. I had ChatGPT generate these numbers. So this is supposed to represent the number of hours that different customers spent using a software during its 30-day free trial period. So this is a small data set, so it's a little bit easier to work with by hand. And we have a list of numbers here starting from 1.5 and going all the way up to 20. And again, these numbers represent the number of hours that each person in this data set used this trial software. So if this was part of a real-world study and the company making the software wanted to try and understand how much people were using their software, especially because this data set would likely be much larger, we want to have some way to describe it without having to look at all of the data values individually. So we might compute the mean or the median, we could find the standard deviation of the data set or the range. We could potentially create a histogram or a frequency table, although for a small data set like this, histograms can sometimes be a little bit challenging. But another option that is kind of a simple computation is what's called the 5-number summary. So the 5 numbers in the 5-number summary are the min, the max, the median, and quartile 1 and quartile 3, and I'll explain what those are in a minute. In order to do the 5-number summary by hand, we need to make sure that the data is first sorted. This data is already sorted, but we need our numbers from smallest to biggest. If they are sorted, it's very easy to determine the min and the max, since those would be just the first and the last numbers. In this data set, the lowest is 1.5 and the highest is 20. Then the median would be the number right in the center of the data set. This particular data set has 21 numbers in it. So the middle number is the 11th value. So there's 10 values below, 10 values above. In this case, the 11th number is 4.8, and that would be my median. Just a reminder, if there were an even number of values, say we had one fewer, the median is the number halfway in between two numbers. So say we had only 20 values and I was looking at the 10th and 11th values, say 4.8 and 5.0, the median then would be 4.9, since that's kind of the average or halfway in between those two values. But in this case, since we have an odd number of data values, it's that 4.8 number. Then quartile 1 and quartile 3 are essentially medians of the first half of the values and the second half of the values. These are also equivalent to the 25 and 75 percentile marks. So they represent sort of the first quarter and the last quarter of the data. So for quartile 1, I want to look at the first half of the list and find its median. Now, there's a little bit of a decision here in whether we want to include the median or not. So because I have an odd number of data values in the entire set, that 4.8 value was in the middle, I have 10 above and 10 below. I can sort of take that 4.8 number out and look at the first 10 values and then the last 10 values as two separate data sets and find the median of each one of those. That's called the exclusive quartile calculation. Or I can include that 4.8 number with the first half and also with the second half. Either one is accepted. That's the exclusion and inclusion versions of these calculations. And they will sometimes give slightly different answers, but they should always be pretty close to one another. In our text, we're going to be using the inclusive version. That's the version we'll look at in Excel, although Excel can do both of these. So because we're using the inclusive version, I'm going to include that 4.8 median with the first half of the list. That gives me 11 data values, and then I find the median of that list. So the median from 11 data values would be the 6th data value. 1, 2, 3, 4, 5, 6. That is 3.0. And then I do the same thing for the second half of the list, again including the median. So that is 11 data values, and I take the 6th one again. 1, 2, 2, 3, 4, 5, 6. The sixth data value in this list is 7.0. So we might just look at the 5-number summary on its own, but it can be really helpful to actually plot these values on a number line and create what's called a box plot. So if I take this this 5-number summary and create a number line, I'm just going to plot each of these values as a little line on the number line, and then I'm going to draw a box plot. So my min is 1.5. I'm going to put that about 1.5 on the number line. And I'm drawing this above the number line so I can see the numbers underneath. Quartile 1 was 3, so I'm going to draw a little line at 3. The median, or you could call this quartile 2, that was 4.8. That would be right about here on my number line. Quartile 3 is at 7, and the max is at 20. So I'm starting with just little vertical lines placed above the numbers at their respective places on the number line. Then I'm going to create a box and what we call whiskers. So I'm going to use the quartile 1 and quartile 3 lines as the sides of my box. So I'm just going to kind of connect the top and bottom of those lines. This is a little wiggly on the screen, but I get a little box where the left and the right hand sides are quartile 1 and quartile 3. And then somewhere in the middle we'll have the median, which is a little vertical line that represents, that middle mark. The median can be anywhere within the box. Sometimes the median is the same as quartile 1 or quartile 3 if we have a lot of duplicate values, but we should expect to see the median show up somewhere in that range between quartile 1 and quartile 3. And then for the min and the max values, I connect them with a horizontal line towards the middle so that they end up looking like long kind of tails with a little vertical line on the end. Sometimes these are called whiskers or box and whisker plots. And so I get the box, which represents the middle 50% of data. So in this case, the range from 3 to 7 contains 50% of all the data values, and that would be true for any box plot. So that quartile 1 to quartile 3 contains half of the data within that little range. That means that each tail or whisker contains 25% of the data. So a quarter of the data values are between 1.5 and 3, a quarter of the data values are between 7 and 20. So the box plot gives us kind of a simple picture of how the data values are distributed. It can tell us a lot of the same things as a histogram. It has a little bit less resolution, but they're a little bit cleaner to look at because we're not considering all the different data values and their frequencies. We're just kind of grouping our data into quarters or quartiles. So for example, I can see that the sort of typical, or in this case the median, the typical number of hours that someone used this software was about 4 to 5. I can also see that the majority or half of all the people who used this trial software used it between 3 and 7 hours. That's represented by my box. And I can also see that this data set has a strong right skew because the maximum is, or the right-hand tail, is much longer. It sort of extends out much further from the box than the left side. So that indicates that we had some people, a small number of people using the software for a lot longer, but most people were using it on the lower end. So 75% of people used it for 7 hours or less. So we can get this nice high level picture of how these data values are distributed. Another thing that box plots can be really useful for is comparing related data sets. So here I have, this is actually the same box plot plotted in red on the screen. That's the one that's below. That had the min of about 1.5, the max of 20, and then my box from 3 to 7. And then I have a second box plot above that's representing a different software. So the original data set was from a productivity software, and we can see how much people used that trial. And then the new data set is from a specific CAD software. So the min on the CAD software boxplot is at 2, the maximum is at 13. We can see our box going from 7 to about 10.5, and the median line in the center of that box is at about 8.5. So when we plot these two related data set, their box plots on the same number line, we can easily compare them. So I can see that the median usage of the CAD software was higher than the median usage of the productivity software. That median line is to the right for the CAD software. And comparing the boxes, the majority of CAD software users used between 7 and 10.5. The majority of productivity software users used between 3 and 7. So we can see that the typical usage, the majority usage numbers were definitely higher for the CAD software than the productivity software. We can also compare their ranges. So the spread of the CAD software numbers is significantly smaller than the spread of the productivity software ranges. And there's a little bit different skew for the CAD software. So it is a little bit more symmetric, actually a little bit skew left. So that might mean that the productivity software users mostly didn't use it that much, but there are a few people who really liked it and used it a lot. And the CAD software users maybe were a little bit more certain about using that software, and more of them used it for longer, and a few people used it for not very much time. So these side-by-side box plots are really nice for comparing different data sets. Versus if we tried to graph a histogram for each one of these, it's harder to kind of line them up side by side. One last thing I'll mention in this video is if you are creating box plots in Excel, Excel makes really easy box plots, but they do create their box plots vertically. And as far as I'm aware, there's not any easy way to make a horizontal box plot without a lot of fiddling around with the data values. So I'm showing here what the box plot for the exact same two data sets that we were just looking at would look like. So the number line is vertical in this graph. So we see 0 at the bottom up to 25. The blue box plot, or the one on the left, is for the productivity software. We have a little legend underneath here labeling the colors. And I can see the lines go up and down, and the boxes are oriented sideways. So the line through the center of each of these boxes represents the median still. Those are still at the same values, but Excel also adds a feature that typically will show up inside the box. So on the left-hand box plot here, we see at the bottom the tail starts at about 2-ish, and then it goes up to where the box starts at about 3. Then the median line shows up in the middle of the box at about 5, and then just above that there's a little X, and that X represents the mean. So the mean is not typically considered part of the 5-number summary, but Excel does include the mean in its box plots. You can see that the mean in this blue or first box plot is higher than the median, and that's indicating that right skew that we saw in the data. The upper portion of the box plot represents that quartile 3, which I believe was 7. And then the other difference that we saw from the other one is that my tail or whisker doesn't go all the way to 20. It actually stops at, I think that's 14. And then up at 20 you see a little dot. This is called a modified box plot. And just by default, Excel will take any values that are considered outliers, and they remove them from the whisker and plot them as individual values, which kind of helps us get a better sense of the data, right? If I'm only looking at the previous version and I see this super long tail up to 20, I don't know if that represents numbers spread out kind of evenly from 7 to 20, or maybe most of the numbers were close to 7 and there was just one value at 20. So by removing the outliers, we get a little bit better picture of the data set as a whole. The second box plot from the CAD software does not have any outliers, so you don't see any extra dots. If you'd like to learn how to create box plots in Excel, there is a separate video about that. And if you'd like to learn how to identify outliers using the interquartile range, there is a separate video about that. That's it for this video. Thanks for watching.